Let us solve a classic example of equilibrium. So here we have a uniform meter rule of weight 0.3 kgf is pivoted at 25 centimeter mark and held horizontal by a force F applied upwards at 100 centimeter mark. Find the value of F. So before solving any numerical, what is the first thing you will do is you will try to make a rough diagram. Okay, so let us try to make it. Okay, so here I have the rough diagram. So what you can see is the ruler is pivoted at 25 centimeter mark. So this is approximately 25 centimeter. This is 100 centimeter mark and this is 0 centimeter mark. Now it says that the weight of the ruler is 0.3 kgf. You think where will the weight of the ruler act? It will act at its center of gravity. So the center of gravity of the ruler will be at 50 centimeter mark, exactly at the center. So we can imagine that the weight of the ruler, the force is acting in this direction and the value is 0.3 kgf. And there is a force which balances it. Its value is F and it is in upward direction. It says that it is held horizontal. Horizontal means it is in equilibrium, stable equilibrium, which we just studied. So in stable equilibrium, what is the condition? The condition is that the clockwise moment and the anti-clockwise moment, they both should be equal. So first of all, let us find out which force is bringing clockwise moment. So you can see this force, the weight of the ruler, it will tend to bend the ruler like this, in this direction. So that means it is bringing clockwise torque. And similarly, if you see the force, it will tend to move this ruler in this direction. So it is bringing anti-clockwise moment. And we have studied that the algebraic sum of clockwise moment and anti-clockwise moment that should be equal to 0 in case of stable equilibrium. So let us calculate the clockwise moment first. The value of the force F is 0.3 and the distance between these 2 points, the pivot point and the force, it is 25 centimeter, right? So we can say that clockwise moment is force that is 0.3 multiplied by the distance. So that is 25. Okay. And this will be negative because it is clockwise. And the anti-clockwise moment, it will be equal to F multiplied by whatever the distance is from the pivot point. So from pivot point 25 centimeter to 100 centimeter mark, I have a distance of 75 centimeters. So F multiplied by 75 centimeter. And this will be plus positive because it is anti-clockwise. And the sum, algebraic sum, should be equal to 0. Now let us solve this equation for F. I can take this part to right hand side. So it will give me F multiplied by 75 is equal to 0.3 multiplied by 25. So you can see this becomes same as our stable equilibrium condition. Clockwise torque is equal to anti-clockwise torque. So here I have this is anti-clockwise torque and this is my clockwise torque. So they both are equal. Now let us solve this. Also, if you see, I have not converted centimeter to meter SI units. That is because even if I convert it into meter, it will ultimately get cancelled out. So I'm not converting it. I directly solve it. So F will be equal to 0.3 multiplied by 25 upon 75. So this gives me 0.1. 25 and 75 gets cancelled out, and these two get cancelled out. So it'll give me 0.1 kgf, because 0.3 is in kgf. So my final answer will also be in kgf. Had it been in Newton, my final answer would have been in Newton. Now let us try solving one more example, classic example. Before watching the solution again, I want you to pause the video, think about the solution, and then come back again. Okay, so what does it say? A uniform meter rule of weight W is pivoted at 70 centimeter mark. If a force of 2 Newton placed at 100 centimeter mark keeps it in equilibrium, then find out the weight of the ruler. As I said, first thing which we will do is we will make a rough figure. So here is my rough figure. This is 70 centimeter mark where the meter rule is pivoted, and as we saw in the last numerical, the weight of the ruler will act exactly at its center. So it will act at 50 centimeter mark, and it is given as W. Now imagine what kind of torque this weight W will give. It will give anti-clockwise moment. So it will give me a torque in this direction because weight is in downward direction. So it will tend to move the ruler like this in anti-clockwise direction. In order to balance this, where should be 2 Newton kept? So it is given that 2 Newton is kept at 100 centimeter mark. So where will the direction of force act? It will act in this direction, 2 Newton. And this 2 Newton, it should give me a clockwise moment like this, because this is the pivot point. So it will tend to move or turn this ruler in clockwise direction. So if it is in equilibrium, then I can apply the condition for stable equilibrium. Clockwise moment is equal to anti-clockwise moment. So first let us find out what is clockwise moment. So from here to here, the distance is 30 centimeter. So I can write down force is 2 Newton. This multiplied by 30 centimeter. This should be equal to W, that is the force of weight of this ruler. This multiplied by the distance from the pivot point. So it is 20 centimeter. Here also you will note that I'm not converting 30 centimeter and 20 centimeter in meter, because ultimately when I solve the equation, they will get cancelled out. So let us solve this equation for W. So W will be equal to 2 multiplied by 30 multiplied by 20. Sorry, divided by 20. So this gives me 3. So finally, it gives me weight of the ruler as 3 Newton. Because the weight balancing it is in Newton, the final answer will also be in Newton. Thank you so much, students. If you have any doubts, please write down in comment section below. I'll try to answer it as much as possible. Happy learning.